Hello there, my name is Cameron Glenn, and welcome to my Volcano interactive presentation. So for this week, I was asked to bring a water bottle, some baking soda, some vinegar, and a paper towel right here. But I also brought a bowl so that way I don't make as much mess on my desk. And for this presentation, let me just adjust my camera right there. I apologize for the glow. Let's see, camera right there. We're going to be mixing the baking soda and vinegar together in the water bottle, which I'll have right here inside the bowl right here. So I will get back to you as soon as I um, put my baking soda right here on in the paper towel and get it inside the bottle. All right, so we're back. I got the baking soda in the paper towel and is inside the bottle right now. Um, Let me see if I can move this glare out of the way a little bit. What if I just turn it clear? Okay, yeah, that'll work. So next step is to add some vinegar, and we are about to see what happens. Although from the title of this experiment, I think people can probably guess what's about to happen. And if you're going to try to get it a little bit closer so people can see. Not a whole lot, but as you can kind of see in the camera right there, looks like the baking soda and the vinegar did react. It's kind of fizzing. Let me see if I can put in some more and make it a little bit more clear. But basically, the baking soda and the vinegar are reacting quite substantially. Here, I spilled a little bit on my desk there. I didn't want that. And if it were to, it's up to about right here, as you can kind of tell. And it's not bubbling out like a volcano, simply because my water bottle is so big right here. So I guess I didn't need the bowl, but um, in terms of what's going on, one thing to note when usually working with a acid and a base is that it ends up creating a neutralization reaction where normally when you mix an acid and a base, whether it be strong or not, um, it'll usually create oxygen, no, not oxygen, water and a type of salt. I actually did a little bit of work on a card right here. Let me see if I can get that into camera view properly. And this is the actual chemical formula right here, where we have the baking soda and the vinegar right here reacting. And I'll read the card off to you when I did the calculation. The product of mixing these two ended up being the gas CO2, water, and we ended up with sodium donating a electron over to give me a second. I'm gonna pause the video. Pause for a second. I was trying to read off the last bit, like read off the name of this last bit right here in the chemical reaction down here. It's calcium acetate is what that ends up forming. Anyway, so as I have already mentioned in this video, normally when a base and an acid mix together, it creates a type of neutralization reaction. When in this case we have a weak acid and a weak base with baking soda and vinegar. Normally, if you mix a strong strong base and a strong acid, they will ionize completely in an aqueous solution, like what you would normally see with this kind of a reaction, and they will may or may not have a sorry for the pause there. Yeah, all strong whenever strong and bases and acids mix together, they'll ionize completely in a soluble solution, and they will create water and a type of salt. In this case, since we may have mixed a weak base and acid, typically what happens is that they don't ionize completely in an aqueous solution. We still get an aqueous solution, as you can see right there, or a soluble solution, depending on what it is you want to call it. But when they mix, they end up with, as I have here, carbon dioxide, water, and we have a situation where the sodium from the vinegar ends up donating a electron over towards the calcium acetate that's going on here. And what that means is that the solution that we got here didn't ionize completely when they are mixed, and that we actually ended up with another acid, I believe, with the calcium acetate. We ended up with another acid and another base right here. It's just that there was a transfer of electrons between two different um, products of the solution right here, and of course we ended up with water and CO2 in the mix. So that's pretty much what happened. Basically, when you mix baking soda and vinegar together, since they're weak acids and bases, they're not going to ionize completely. So you still got out water, as I showed you on the card, but you also get out CO2 and you get out a new acid and base out of it as a result of an exchange of electrons that's going on. So that's pretty much what happens when you mix baking soda and vinegar together. And I will be looking forward to seeing you guys next week with my new interactive lab. See you later.